Alright, we are live. I'm going to put the link up in the Google Classroom for anybody who is ready for it. If you don't already, you should be subscribing to my YouTube channel. So those of you who are tuning in, make sure that you subscribe to my YouTube channel so that you can see when these videos are going live. Paste my URL here. All right. Hey, Rocio. Thanks for tuning in. Good to see that someone's here. If anyone has any parts of code.org they want me to go over, just say something, type in the chat here. And I'll go over any part of code.org. So I'm going to make Unit 1 and 2, actually Unit 1 we don't need, let's make that hidden. Unit 3, I'm going to go in and make everything visible in case there's questions from previous sections. If people want to use this time to catch up on work that they hadn't done before, I am here to support and answer any question about any section of code.org. Just let me know which lesson and which level you want me to review. So 8, 9, 11, 12, 13, 14, 15, 16, 17, all visible. We'll leave it at there. Oh, collisions is lesson 18. Okay. I'm going to open that up just so it's there in case people get to lesson 18. Still looking for questions. Hey everybody. Good to see there's some people joining the live stream here. My plan is to be doing this every weekday maybe even on weekends, depending on how much of a desire there is for it. I'm always happy to help people learn how to code. So every day at 10 o'clock a.m. seems like a good time. I'll be doing this live stream. So if you have any questions on the code.org curriculum or previous assignments in my class, I am here to answer. Lesson 17, okay. Would you like me to go over which level? Which levels of lesson 17 do we want? All of them? Let's find lesson 17. Sprite, here we go. Velocity and the counter pattern. Complex sprite movement. Let's go to the overview. See if my stream is still connected here. So you should see the overview right now. There seems to be about a 10 or 20 second delay in between my live stream and what I'm actually doing. So when you ask a question, it might take me 10 or 20 seconds to see that question and respond to it. Okay, so I'm being asked to go over all of lesson 17 and part 12, it looks like, as well. So we'll start from the beginning and get up to part 12, and maybe I'll just go through the whole lesson. We'll see how long this takes. Alright, so in our overview for lesson 17, the class learns to combine the velocity properties of sprites with the counter pattern to create more complex sprite movement, such as simulating gravity, making a sprite jump, and allowing a sprite to float left or right. In the final levels, the class combine these movements to animate and control a single sprite, and build a simple game in which a character flies around and collects coins. So we're going to be combining, it looks like, combining the velocity. If you remember, using velocity x and velocity y allowed us to give something a certain speed. If we combine that with the counter pattern, we'll be able to change the speed as the program runs. So let's hit continue here and take a look at part 2. As you can see, I haven't even finished all of lesson 17 yet. I have these green bubbles up till here, and then the purple ones, or the empty ones here I haven't gotten to yet. So some of this I'll be looking at for the first time on the live stream. Alright, so this is a prediction, so we don't have to write any code here. We're just predicting what's going to happen. Using the counter pattern with a sprite's x and y property makes a sprite move smoothly across the screen. Right, if you remember, like sprite X would make it move across the screen horizontally. Velocity X would make it move horizontally. Velocity Y makes it move up and down. And now we can see something going on here where it looks like we're combining the velocity with the counter pattern. I have some drawing tools. I'm not sure if these are going to show up on the screen or not. Let me check. So this here, we're taking velocity, adding to it, right, and then storing it back into the velocity value, which is letting us change the velocity throughout the program as it runs. So when we do hit run here, I'm curious if that red marker shows up. I'm just checking my live stream now to see if the marker that I used, I don't think it does. No, I'll have to do a whole screen capture. I think it's just capturing my... Okay, well that's not a big deal. Alright, so anyway, so as you can see, when we hit run, the sprite starts moving slow and then gets faster and faster and faster, and so the speed is increasing as the program runs. We could see, if we open up our debug console down here, the watch, we can watch sprite 1 dot velocity x. So we can see as we run the program, Sprite 1 velocity x, right now it's undefined. We run, and the velocity is increasing as the program goes on. Like imagine if you're driving a car and you put your foot on the pedal and all the way down, the car speeds up, right? The speed increases. In physics, we call it acceleration, but I'm not sure that matters so much for this. So let's move on, hit finish, and move on to number 3. Checking for questions. All right, I will get to part 12. We will get up to lesson 12 for sure. I want to build up that way so that anybody watching can see how we get up to level 12. That's way up here. As you just saw, using a sprite velocity x property with a counter pattern will change the sprite's velocity during a program. This makes the sprite speed up. Do a little practice using this pattern yourself. Okay, so do this. The program already makes a car move across the screen, but just going very slowly. Use the counter pattern with the sprite's velocity x property to make the car speed up. Counter pattern. Oh, I already have the answer programmed in here. So I'm going to start over so that you can see what this looks like without the answer. Okay. So we hit run, and right now the car's velocity is at 0.2. So it's moving, but it's moving very slowly. So we're going to use the counter pattern with the velocity x property to make the car speed up. So we can update our sprites here in the draw loop. And all we have to do to use the counter pattern, sprite velocity x, so in this case it's car, and then we want to add sprite.velocity x, that's again going to be car, plus we could do 0.2. You want to keep these numbers pretty small because the loop runs very quickly. So if you use bigger numbers like 1 or 2, it's going to just fly off the screen before you even see it. So here it gets slower and then faster and faster and faster and faster as it moves off the screen. We could maybe see it a little better if I did 0.4. So we're using the counter pattern to make the velocity change as the program runs. Pretty cool. All right, how many do we have in here? I have 4 people viewing. That's a good start. We still got 4 of us in here. All right, hopefully you're sticking with me. We're going to move on to level 4. The rock should speed up as it falls down the screen. Can you use the same counter pattern with velocity y inside the draw loop to make the rock go faster as it falls? So we're just practicing here a little more of the counter pattern. The answer is right here. I already have it programmed in. It's just like what we did in level 3, except we're using velocity y instead. And then I added rock.rotation speed here on line 4, just so the rock was spinning as part of the challenge. And what this does is it kind of lets us emulate gravity, right? Because when something is falling due to gravity, it starts at at 0, and when it starts falling, it gets faster and faster and faster and faster and faster as it's falling. So that's what using the counter pattern kind of lets us emulate. It lets us make it look like there's real gravity here, which will be really cool to add into our movement as we're building games. When you make a frog or a character in a game jump, and if you want him to fall back and make it look a little more realistic, this is definitely a good way to do that. I'm not seeing any additional questions. If I go over a lesson, if I'm going over something that's confusing and you need me to stop, just say so in the live chat, and that way I will know. If you have any questions as I'm going through this, please do not hesitate to type into the chat. All right, number 5. I'm going to restart this one. Version history, start over. This program makes it bubble rise up the water. Can you make it go faster as it rises? So we have this bubble in water here traveling up. We want to make it go faster as it's moving up. So again, this is just using the counter pattern with velocity. We are going to make bubble velocity y get the value of, let's use, oh, actually, do we want addition or subtraction? Let's think about that here, because it's moving up. And as we know, if we look at our grid, don't reload. No, don't do that. Oh, man. Whoops. That's okay. It'll reload in a second here. Show grid. There we go. So the y value is 0 up here and 400 down here. So if it's going to move up, it's going to need to, we're going to need to subtract, right? It's going to have to be subtraction that makes it move up. So to make it move up faster, we actually shouldn't be using addition. We should be using subtraction. Bubble dot velocity y minus, could do 0.3. And now it speeds up as it moves up, getting faster and faster. Cool. I'm going to pause here for a second in case anyone needs a minute to catch up. Again, if you have any questions, let me know. I'm glad I still see we have 4 people viewing. Hopefully that number grows as I continue doing this on a consistent basis. I was also considering opening this up to additional students and other schools that might need help, which I think would be a pretty cool idea. And attendance in these tutorials is not mandatory. Just in case you're wondering, I'm not checking if you're here and grading you based on that, but completing the lessons is something we'll have to do. So I think doing this via YouTube Live is going to be a really great way for me to help you guys through these lessons. Ideally, I don't want to be showing you all the answers all the time, and I am going to be looking for other ways to make this a little more interactive so that you guys can answer questions, maybe make it a little more like an actual classroom so that I'm not seeing questions on a 20-second delay. I don't see any questions coming up now, so I assume we're good to go. So maybe on this one we'll do some thinking. We'll think through this problem. Version history, start over. So this one involves a little more coding. Okay, now that you've had some practice speeding things up, can you use the counter pattern to slow sprites down? So do this. The car is going to run into the water. So we can run the code and see the car is going into the water. Oh no! You'll need to use the counter pattern to slow it down. Use the sprite.velocityx block with a counter pattern to slow the car down by 0.25 as it moves across the screen. What do you think will happen when the car finally stops? So if we're using the sprite velocity x to slow the car down, right, we're going to be subtracting 0.25 every time. The value here is going to start at 10, and it's every time it runs through the loop, it's going to be losing 0.25. So it's going to go down to 9.75, 9.5, 9.25, 9, 8.75, and so on, all the way down to 0. But what's going to happen once it gets to 0? When it gets to 0, is it going to stop subtracting magically? No, we'd have to add code to make that happen. So if we just have the counter pattern, it's going to keep losing 0.25 every loop. And let's see what happens as a result. So let's go sprite velocity x. And this is the same as all the other ones, only now we're slowing it down by using subtraction, right? That's going to make it try to move more to the left. It's going to start moving to the right, but we're going to subtract from the velocity to slow it down to 0. So car dot velocity x minus 0.25. Reset and run. And then look, it slows down, stops, oh, and now it's moving backwards. Interesting. So it didn't stop, it went in reverse and started moving backwards. If we watch, let's open up our console here. Let's watch velocity x. So reset. It starts off undefined. When we start the code, it's going to start off at 10, and then as each loop runs, and then it starts going negative. And now at a negative velocity, it moves to the left. So let's add code that makes the car slow down only if its velocity x is greater than 0. That's going to make it stop, right? We can use some control here. We can say if car dot velocity x is greater than 0, then do that counter pattern. So now it goes here and then stops. Cool. All right, that's it for lesson 6. Do you need me to go back over level 4 again, Mario? I can go back to level 4 later on. Is the video going to be here all week? Yes. It should. I'll make sure the recording is posted. And if the recording doesn't get posted for some reason, I'll remake a new video and add that. I know you may not be able to sit here and watch the live stream for the entire hour if you can only sit in for 10, 15, 20 minutes. If there's something else going on, or you want to watch at a different pace, I totally get it. Okay. So we're going to run the code. Oh, nope, version history. Start over. I'm going to get up to level 12 first, and then I'll head back to level 4 to answer Mario's question. So in the last level, you slowed the car down with velocity x. It looked like the car was getting pulled to the left. If you use the same pattern with velocity y, it will look like your sprite is being pulled down, which is exactly what gravity does. So the rock is thrown in the air but never falls down. Use sprite velocity y with the counter pattern to slow the rock down and then fall the other direction. Experiment with different values in your counter pattern. Do you want it to slow down quickly or gradually? What looks the most realistic? And then discuss, so think to yourself at least, why are you setting the rock's initial velocity outside the draw loop? Why are you changing the sprite's velocity inside the draw loop? So I'm not going to give the answers here because this is an assessment one. So I'm going to write some comments that might help. So use the sprite velocity x block with the counter pattern to make the rock slow down. So we're going to do that in here. So on line 8, that's where you want to use sprite, or in this case, rock dot velocity y to slow down the rock. Think about, is it going to be subtraction, addition, or subtraction? So that's something to think about as you're making your answer. Experiment with different values. So when you use rock.velocity y equals rock.velocity y, are you adding or subtracting? And use different numbers. Maybe try 0.1, 0.2, and see what looks the most realistic when you run the code. And why are you setting the rock's initial velocity outside the draw loop? Why are you changing the sprite's velocity inside the draw loop? So the initial something to think about here. This initial velocity is being set outside the draw loop because anything we want to happen or anything we want to set up when we run the code, when the code starts, needs to be outside of the draw loop. The draw loop runs in a loop over and over and over and over and over. So if we want to change the velocity, that has to happen in the draw loop. Anything that we want to change as the program runs needs to be in the draw loop. So let me know if you have any specific questions about level 7. And I'll move on to 8. Skip ahead to 8 for now. If you can't figure out level 7, if you need some extra time with level 7, you can always jump back to it. I'm going to take a second to set this one up. Increasing a sprite's Y velocity inside the counter pattern can simulate gravity. By adding user interactions, you can make your sprite appear to jump as well. For starters, you'll make a single jump and then make it more realistic looking in the next level. So a sprite has already been created for you that falls because its Y velocity is increased inside the draw loop. You'll need to make this sprite appear to jump. A lot going on here, so let's break this down. Inside the if block that checks whether the up arrow has been pressed, set the sprite's Y velocity to -5. So the if block, that's checking when the up arrow is pressed. That's right here on line 11. So inside of that if block, set the sprite's Y velocity to -5. Alright, so sprite.y. The sprite's name is character. Make sure I spell that right. CHARACTER. Character.velocity_y gets -5. So, and this is the code here that's simulating gravity, which is pretty cool. So, let's see. We're going to hit run. And the sprite starts at 200, 200. And it's falling and falling and falling, right? So this is simulating gravity. That's what's making it fall down. And then when you press the up arrow, so I'm going to press the up arrow right now. I'm going to try to find a way on this live stream to let you see what buttons I'm pressing. I think that would be really cool. I'll look into some more tools for that. But what this is doing, when I press the up key, it is immediately changing the velocity to -5. So we can actually, really cool to set up a little watcher for this. We can see what's happening to character.velocity_y. Make that so we can see it. Reset, run the code again. So notice the velocity y is going up. Oh, and now it's -5. So every time I press the up arrow, what this code is doing on line 12, 11 and 12, if I'm pressing the up arrow, it immediately resets the velocity to -5. Which is a really cool way to make it look like our character is jumping, which would be a cool way to make a game. One of the many ways we can make games here. So I'm going to hit finish on level 8. Check for questions. And yes, addition is correct. Sorry, those chats come in. I need to make it so that I can see your chats while I'm streaming this. I need a second monitor or something. It's my first time doing this, so we're kind of seeing how it works. I'll try to make improvements as we go along. So again, one of my goals is going to be to make this a little more interactive immediately, and not have a delay so that I could ask a question and you guys can respond. Maybe I could ask a question and then I could just wait for 10 to 20 seconds and see if I see responses in the live stream. But for now, we're just going to press forward with code.org. Good. All So you're now using the counter pattern with the sprite's y velocity to simulate gravity and jumping. Cool. So we're already simulating gravity and making our sprites jump. If you use the sprite's x velocity in the counter pattern, you can make the sprite float from side to side as well. Very cool. In this level, you'll make your sprite start floating to the right when the right arrow is pressed. Add an if statement inside your draw loop below the one you created for the up arrow. Alright, pretty straightforward step right there. Add an if statement. We can all do that. It's specified below, so we're going to go here, below. Use the key down block to make the if statement respond to when the right arrow is pressed. So use the key down block, here's key down, to make the if statement respond when the right arrow is pressed. So that's going to be key down. And do we want to leave this as key down up? No. So think about what we want to change this to. If they're telling us to respond to when the right arrow is pressed, up, down, left, right, space, it's going to be right. Inside the if block, use the counter pattern with the sprite.velocity x block to add 0.1 to the sprite's x velocity. So, they want us to use the counter pattern, right? The counter pattern is variable gets variable plus a number. In this case, addition. So we'll do sprite character dot velocity x gets. You can drag and drop the bubbles. I like to type because I think it's a little faster. Oh, plus 0.1. So when you had the blocks in, it'll look like that. You can drag the math block for addition. And we're using the counter pattern to do this. So when I run the code now, the up arrow makes him jump and the right arrow makes him float to the right. Very cool. All right, what about the left arrow? We'll make the left arrow work in the next level. So let's move on to level 10. Loading, loading, loading. Taking forever to load. I bet code.org is a little slow right now because a lot of people are using it. Everybody's at home practicing code. Okay, floating left in the last level we got detailed instructions on how to make the sprite start floating to the right. This time we're going to do it on our own. You should be pretty comfortable with using velocity and the counter pattern together at this point. If you're having trouble, talk to a neighbor or review some of the past levels. Add the code to your draw loop that will make the sprite start moving to the left when the left arrow is down. Make sure you're using velocity and the counter pattern together. So take a minute and do this on your own. I'm going to step away because I need to get the charger for my laptop. My battery is running low. So take a minute and try to do this on your own. You're going to be adding code that makes the sprite start moving to the left. So once I am back in a minute or two, I'll show you the answer to make sure you get it right, but I really want you to try to do it on your own to make sure you're understanding how these pieces all fit together. So try to code basically the same thing, right, but for the left arrow, and think about how it's going to be different when you want to make something move to the left instead of the right. So try to code that now. I'll be back in just a minute. Should have done that last week. Be careful because my mic is live, so people could probably hear me. All right, I am back. My computer is plugged in. Let's go over the answer here. Control if key down left, and I'm going to copy this line of code. But instead of plus, we're going to change it to minus because we want it to move the other direction, right? Plus will make it move to the right, minus will make it move to the left. Actually, I don't know which way this is going to show up on my screen. If my screen is going to be backwards. Okay, well, let's run the code. And if we go to the right and left, jump. Right, left makes it move to the left, right. So we're kind of speeding up and slowing down left and right. Hey, get this fun little jumping game here. This is pretty cool. This is awesome that we get to build this. This is some really cool stuff. I wish we had gotten to this earlier in the school year, because this interactive game that we're making it's a lot of fun. All right, finish. Continue. Let's move on to 11. Ah, 11. All right, lesson 17, level 11. In the next few levels, you'll add to your program to make a simple game. In this game, the player will collect points to increase the score. This is a good chance to see how different kinds of movement can affect the way a game feels. It'll help your programming skills. In this level, you'll be adding a new coin sprite to the game. You should be working at the top of your program outside the draw loop. So use create sprite to make a new sprite. Give it a descriptive name such as coin. So let's do that first. We want to create that sprite, so that's under sprites, var sprite, create sprite. We're going to name it coin, and that makes a coin sprite. Cool. Right now, that coin does not have an animation though. Right, when I run the code, there's just going to be that block sitting in the way, and there's the other character behind that. So our animation, as you can see, we already have the coin as part of our animation, which is cool. You could change the color if you wanted to or something, but we don't have to do all that. So the animation's already stored in there, so we can use coin.setAnimation to set the animation of the sprite to coin. And now there's a coin on our screen. Pretty cool. So use the create sprite block to make it. We did that already. Step 2, use the sprite.x and sprite.y properties of the sprite to give it a random x and y position between 0 and 400. So there's a few ways we can do that. You can put the random numbers in here, or we can deliberately create sprite.x and sprite.y. So coin.x and coin.y to be a random number between what and what? Between 0 and 400. So random number 0, 400, random number 0, and 400. Cool. In the animation tab, there is already a coin animation. Use the sprite.setAnimation block to give your sprite this animation. Test your code before moving on. When you run the game, you should see a coin sprite appear somewhere randomly on the screen. Run. So the coin is going to appear in different places on the screen, right? Because we're telling it random number, which is pretty cool. In the animation tab, yep, cool. Test your code before moving on. So when you run the game, the coin sprite should appear randomly on the screen. So we're good. We are set up on 11. Reset and run. All right, so all the code that we added is just these 4 lines here. Line 3, 4, 5, and 6. I think we're going to use that is touching block pretty soon here. What are we at? Oh, still got 4 people on. All right. When your character touches the coin, you should reset it somewhere on the screen. That makes sense. So when our character touches the coin should move around. Place an if block inside of your draw loop, right? Our if blocks always go inside the draw loop. I don't really think it matters where, because these are all individual things controlling the speed. So the top, the bottom, I like to add in order. So I'm going to add an if block here. So I'm going to work at the bottom of the code for now, and then we'll change that if we need to. This isn't my first time looking at these three levels, so I may make a mistake. Hopefully, I don't. Use the sprite.isTouching block as the condition to detect when the character touches the coin. So if you remember, our condition is always in this first block right up here. So on line 24 in this area, that's where we put our condition. If this happens, right? If key down right, if key down left, if sprite is touching. So under sprites, we're going to find the is touching. Oh my goodness. Collide, bounce, bounce. What is all this stuff? All right, well, we're going to learn some fun code soon, it looks like. But here we have sprite is touching target, so I'm going to do character is touching coin. So that detects when the character touches the coin. Inside the if block, write code that sets the x and y position to random numbers between 0 and 400. Hint, you've already written this code elsewhere in your program. So this will be really easy to do, right? We can just, boom, copy, and paste. Oh, where did it paste? Whoops. So I'm going to drag these down, 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 down. Did this the hard way, didn't I? Coin.x and coin.y. So you want to make sure you have that. I'm going to move this up here so we can see more of my code as a whole picture. All right, so there's coin x and coin y at the beginning of our code, and we're also putting that code here inside of character is touching coin. And what that's going to do is when the character and the coin touch each other, it's going to make the coin move to a different position. So let's see how that works when we run our program. So we're going to move up, up, and, oh, there we go. And now we have to go down. Try to get the other coin. See if that gets it. I hit it too soon. And got it. Hey, who'd have thought I'd get paid to play video games? That's what I'm doing right now. Playing a video game at work. All right. Finish. That's the end of part 12. So that's really cool because now we can make the score go up when those things happen. So it'll be like playing a game of Mario. When you collect a coin, you get a point. So now we need a scoreboard. Make it your own. You have the basic mechanics of the game in place. Time to make it your own. What do you want to happen? Should the character get points when it collects a coin? Can you add a scoreboard like you did in the last lesson? Do you want to make another coin? What about a bad coin that takes away points? Make at least one improvement to the game that makes it your own. Be prepared to share your changes and improvements with your classmates. So this would be a really fun opportunity. It's a shame we're not in the classroom right now, actually, because everybody could make a different improvement, and then we could all play each other's games to see the different improvements that we made. So basically what this section is asking you to do is to just add something to the game that you want to add. So we can make a scoreboard, we can make a good coin and a bad coin. So at this point, it's completely free for all. Do whatever you want. I'm going to make this a little complicated. I'm going to make a scoreboard and a bad coin. So let's get started on how the scoreboard is going to look. So to create a scoreboard, we need to use drawing and text. And the text is going to say score. And I'm going to place it at 50-50, so it's in that upper left corner of the screen. Yep. And I'm going to use text size to make it a little bigger. So maybe 30. There we go. Nice and big. Score. And add a colon in there. Then I'm going to add some text that's capturing the value of score. Right, so we need a variable called score, and I'm going to place it at maybe 60 and 50. Start there. Here's the problem though, I don't have a variable tracking score yet, so I have to make a variable, var x gets. So we're going to make a variable called score, and it's going to start at 0. And now I have text here. This specifically is capturing the value of score. This is really tricky here. What I did, the important part here is taking away the quotations. So if I reset and run the code, could ignore the sprites for now. Uh-oh. All right, this needs to move way more over to the right. Let's try 100. Nope. Let's show the grid. I want it to be about here. So that's an x value of 160. So let's do 160. There we go. Maybe a little too far. Let's try maybe 150. $150. A little better. So this is capturing the value of this variable. So if this were to change to like 10, the text is displaying that score. Right? Pretty cool. It won't work if you have quotations because we haven't really talked a lot about data types, but when you put the quotations around a word, the code reads it as a word. So it's going to print the word score if I do this, right? We don't want that. We want it to print the value that we've stored in score. So we want to get rid of these quotations, delete them, and now it's not reading the word score anymore. It's looking for a variable named score, and it's reading that variable. Right? If I want to make this even clearer, I could just, do var number and make this number. Right? It's still going to read that code. Cool. So I want to set something up where the score can increase. So when character is touching coin, we want score. Hi, Yari. Who is Yari? I don't think Yari is one of my students. Well, welcome to my YouTube channel. I'm just here live streaming some code.org work to help students learn how to code. So coin.x, coin.y. So sorry, I wanted to increase. I named it number. You might name it something else, but number gets number plus 1, right? We're going to use the counter pattern to take whatever was in number and add 1 to it. So it starts at 0, and now whenever I hit that coin, it adds 1 to my score. Ah, hi Annually. So, boop, score goes up. Good, so this is working how I want it to. We're adding to the score. It's a pretty cool addition. I'm going to go a step further, and I'm going to make a bad coin. Do I have time for this? We have about 8 minutes. I have a meeting with some other teachers in 8 minutes, so I'm going to add some more stuff to this just for the fun. This is completely voluntary. You don't have to do this. But I'm going to take my coin here, copy it, and name this one bad coin. And we're going to color it. Paint all pixels the same color. Let's go with, here we're going to do a dark red. And then we'll make it a little lighter here. And even brighter in the middle. And then the center here, I'm going to make it like a pink. Oh, that did that whole thing. All right, well, it's a very different color, as we can see. So it doesn't need to be perfect. And I'm going to go to sprites, var sprite. And we're going to do bad coin. And we're going to give it the same random number to start. So drag this down here. Bad coin. Bad. So I'm changing the sprites here. Bad coin. Oh, I didn't set the animation. So we're getting this gray square here because I forgot to do set animation on bad coin and animate it to our drawing that I just made called bad underscore coin. And you can just watch this part again. You don't have to do all this. So now there's a good coin and a bad coin. And when we hit the bad coin, what we should do, so I'm going to just copy and paste this code. So if character is touching bad coin, we're going to make bad coin reappear. And we're going to do, instead of +1, we're going to do -1. Oh. Let's go down here. So if character is touching bad coin is going to move to a new place, and we're going to lose 1 from our score. So let's reset and run the code. Alright, so when I hit the regular coin, my score goes up, and when I hit the bad coin, oh no, my score goes down. Oh no, it's negative. Ah! Alright, so we don't want to hit that bad coin, we want to hit the good coin. And this is just one of many ways we can make this more interactive. You could make certain text show up. You could make it, if you hit the bad coin, you can make it say game over on the screen. You can really customize this any way you want. But that's going to be it for level 17, it looks like. So we covered all of this in 1 hour. That's crazy. 14. This is probably just, yeah. So this is just a reference page. If you want to read through, you can use the sprite's velocity properties with the counter pattern that makes the sprite speed up or slow down. So to speed up a sprite that has a positive velocity, you need to add. To speed up a sprite with a negative velocity, you must subtract. So going up, right, to go up, we're subtracting. This is kind of an answer to part 7 from earlier. To go up, we subtract. To go down, we add to y. To go left, we subtract from x. And to go right, we add to the x value. So this also has a guide here on slowing down. I'm not going to read through all this, but you can kind of browse that or use this as a reference page as you're going through the levels if you're confused about how something works. You can kind of read through this. It might make more sense. There's also a translator here. So whatever your native language is, you can translate these pages like so. I'm going to do French just because I know a little French. Let's see how this translates. Translating. Looks like it didn't translate anything. Weird. Ah, okay, there's some translation here. The rest of this doesn't get translated, though. That's unfortunate. It does mess everything up. Maybe don't do that. Maybe that's a bad idea. And translator does not seem to work very well. I'm going to put it back to English. Anyway, that's all the time I have today. If you liked this, leave a comment or comment in the Google Classroom. Yes, this was helpful. No, this was not helpful. If you have suggestions for how I can improve doing something like this, I would love to run a stream like this, maybe once a day, maybe a couple times a week, to be able to provide some support around learning remotely as we are what appears to be transitioning for the time being to having to learn from home. So hopefully this helps, and I will see you guys next time. So long, and thanks for tuning in.